What are you doing?
Well, I'm just trying to calculate the force of gravity on Earth's surface.
How are you going to do that?
Well, I'm going to use Newton's Law of Universal Gravitation.
What is that?
Well, in the form of an equation, it says that the force of gravitation between two objects equals the mass of these two objects divided by the distance between them squared, all multiplied by the gravitational constant, or Big Daddy G.
What's Big Daddy G?
Well, it's actually pretty interesting. It's an empirical value that was first theorized by Newton when he was making this equation, but then wasn't actually discovered and proved to be substantial until 78 years after Newton died, when Henry Cavendish had two tiny masses of lead and used a very, very sensitive torsion balance to calculate the force between them. Anyways, what this equation actually means, if we have two masses, let's call them M1 and M2, and we have a distance between them that we'll call R. Say there's an imaginary line connecting them. Every point on that line is attracted to every single other point because it's directly proportional the forces between them that are attracting to the mass of those 2 points, which should be the same, and the distance between them. So for this particular equation, we know that the force equals M1 times baby G. And what we're trying to do in this equation is find baby G. And what we're going to use is the radius of the Earth and the mass of Earth. And you may be thinking, but we only have one mass given.
Exactly.
Well, you're about to see something real neat.
No way.
So say we replace this F with M1G. We get M1G equals gravitational constant times M1 times M2 over the distance between them squared. Now, if you look closely, you'll notice that there's an M1 on both sides. And if you divide both sides by M1, then it's just going to go away. I know. So now to find baby G, which is the force of gravity on the Earth's surface, we're going to go ahead and plug in some of these given values. So baby G equals the gravitational constant, which we know is 6.67 times 10 to the negative 11th.
Of course.
And then we're going to multiply that by the mass that we have to use, which is the mass of Earth,
Right.
which is 5.98 times 10 to the 24th, over the distance between them squared. And the reason the distance between them sounds confusing is because we're using the radius of the Earth, because we're using the center of the Earth and the surface of the Earth. So that means we're just going to use the distance between the surface of the Earth to the center, which is 6.38 times 10 to the 6th meters. Now, if we go in to put in some units, we know that for Big Daddy G, we got to put newtons times meters squared over kilograms squared. So that means some units are going to cancel out. And when we plug this bad boy into our calculator, we get that baby G equals 9.8 meters per second squared. And that's how you calculate baby G.
Oh my god.
I gotta mess some stuff up.